Hey everybody. Today we are going to learn about three different things. Now that we have some knowledge of switches and lights, we are going to try to make a button that can turn a light on and off by using some basic coding. For those wondering, you could use different hardware other than a button, such as a side switch, but in general, buttons are much smaller than switches. This is why we use them on things like controllers, as they can move more things and do more things. For example, switches have the downside of always being on or off, while buttons can be always on, always off, change when pressed, do something when rapidly pressed, do something when held down, and anything else you could think of. Just think of all the ways a PS4 or PS5 controller, if you're very lucky, or Xbox controller can use their buttons. So with that in mind, we first have to learn about how we're going to tell the Arduino to do something we haven't done before, and that is read when the button has been pressed. To do this, we're going to change one of these pins into something we call a read pin. Read pins really only do one thing. They tell you if power is coming in, or if it's not. While power is in the pin, the Arduino will read the value of the pin as a 1, and when there is no power, they'll read it as a 0. Let's put together an easy example to show you what I'm talking about. On this circuit, you will see that I have a wire coming from number 13 into row 5, so that all of row 5 has power. Right now, that power is flowing into this blue cord, which is going to read pin number 12, which is where we'll read whether it has power or not. And lastly, it goes to the switch, which when activated will go directly to ground. Remember in the first lesson we talked about this, how electricity will always go directly to ground if possible, in the easiest way possible. Right now, the only place electricity can flow, because the switch isn't pressed down, is from 13 into the blue and then into 12. But if I press this switch, it will instead flow into the ground. This means that read pin 12 can read the current flowing when the button is not pressed, because electricity will flow from 13 into 12, and when the button is pressed, it won't read anything, because it would go right through to ground instead of to pin 12. This is very useful for us in order to know what the Arduino is seeing on the board and use that to do things elsewhere with other pins. At this moment though, nothing is happening because I haven't written any code, but the plan is to make sure that the power that comes out of 13 goes to 12, or goes through this switch into ground when the switch is pressed, and then we can use that information to do something else, like turn on a light. So let's go ahead and program that now. So the first thing I'm going to have to do is set the pin modes. This is something you've seen before, where in the beginning of a project you'll type in pin mode, the number of the pin, and then you'll say if it's an output, and if it's an input, a read pin, you will say input. So pin 12 is an input. Make sure it's all in caps, the computer knows what to do with it. Make sure there's semicolons at the end so it knows what it's reading. Great. So now I have pin mode 13 as an output and pin mode 12 as an input. Now I just need to make sure that I'm writing or powering these pins. So digital write for pin 13, that's the only one that's getting power, remember, is going to be high because it's getting power. And now I need to be able to read what is coming to pin 12. To do this, we're going to use a tool called the serial monitor, which you'll see at the bottom here. The serial monitor is just a built-in tool that allows you to see what the Arduino is reading. So to use it, you have to type in this specific bit of code at the beginning, serial.begin 9600. Make sure you spell serial correctly. And then at the beginning, you can type, or at the next line, sorry, in the loop, you can type in serial. This has to be lowercase. Make sure there's a semicolon at the end here. Dot print line. And then we're going to use a new command. So digital write is what puts power into a pin. To tell what a pin is seeing, you use digital read. Why it doesn't read digital or write digital, I don't know. We'll have to invent a new language if we want to know more about that. But digital read from pin 12. I'll put a semicolon at the end of this because it's the end of a code block and I want to make sure the computer reads it. And the last part I'm going to put is delay. You might ask yourself, why am I putting this delay of half a second at 500 milliseconds? The reason is because if I just put the code like this, the serial monitor will spit out as fast as it can what the digital is reading, and it can spit it out faster than I can read it, which means I won't have any idea what it's saying. But this is enough coding for now. Let's make sure it works. So I'll start the simulation. It looks like I have a small coding error, so I'll have to fix that. Let's see what's wrong. I spelled digital wrong. Oh, Mr. Andrew, what a joke you are. All right, there we go. Take a good look at the code. I had to correct a couple things, including capitalizing the S in serial, spell checking my digital, and making sure there were semicolons at the end of every line. And you'll notice that nothing is happening. This is because you need to have the serial monitor on, and when you do, after you clear it, you'll see it's putting out this 1. This means that electricity is flowing just like I hoped it would. It's flowing from 13 into row 5, and then it goes right to pin 12 because this switch is enclosed. Now watch what happens when I close the switch. If I click the button, switch closes, and I'm getting zeros. This means the Arduino knows that I've pushed this button, and when I let it go, so it's a 1, it knows I've let go of the button, which means it is measuring and changing to see what I'm doing with the button. So we can have the Arduino board use this to do things on other places on the board. So let's try something really simple, like making a light. To start making a light, I'm going to have to use another pin to put power into. So I'm going to go ahead and put another pin. In this case, I'm just going to pick pin 4. It really doesn't matter which pin you pick, as long as it's not a pin that's already used. But I'm just using 4 because it's the first one I thought of. Because power is coming out of it, I'm going to make it an output. So now I need to actually make an LED light. So I'll put away my code. I'll get my handy dandy resistor, because we have to have one of those so it doesn't blow out the LED. I'll just put it like this. I want to reduce the ohms to 330 ohms, because that's about the most you'll need for basically any resistor we'll use in this class. I have to start in the anode and go to the cathode, and then the cathode has to go to ground. And then I'll drop it off in this ground rail here, or this ground pin, I should say. Because it's ground, I'll make it black. And I'm doing power from 4 to here, so it's going to go through here. And I'll make it red for power. Okay, so now that it's set up, now I need to go back to my coding. And I basically need to tell the computer what it's going to do with this. Because right now, it doesn't have any instruction on what to put into pin 4. So basically what I want it to do is this. I want it to turn the light off as long as the button is pressed. So to do that, I'm going to use something that's new for us. It's called a Boolean statement. Yes, that is a real word. Boolean statements do sound a little funny when you hear it for the first time, but they're basically ways to compare things. You've already done this in the past with things like greater than, less than, the same as, all kinds of things like that. Booleans are things computers just use to compare. So we're going to use a really simple logical statement. So you're going to type this, if, and you can see when you type it, it turns purple. And then you set a condition or a thing that needs to be one way or the other. And that's what these parentheses are. And if that's confusing, don't worry. It'll make a lot of sense in a second. If digital read of pin 12, I'm going to use 2 equals to say is the same as. Is the same as 0. And then I'm going to put these curly brackets, which are next to the letters P and O on your keyboard. I'm going to type in what will happen. So I'm going to say digital write for pin 4. I'm going to set it to low. So it will turn off as long as the button is pressed. I'll have to turn it on at the start so that way it knows to turn off. So I'm going to include a digital write here as well. Pin 4, high. Include my semicolon here. Include my semicolon here because it's the end of some code blocks. Otherwise the computer won't read it. Okay, so here's what this is basically saying. It's saying if I look at pin 12, because it's reading from pin 12, and I see a 0, which means no power, so that means the switch is pressed and it's going to ground. I'm going to write to this pin, so it's going to go to pin 4 and it's going to give it low, which remember means no power. So it will stop powering this LED as soon as I press the button and hold it. If I let go of the button, however, and it goes back to 1, right now, the light won't turn off because I have this digital write high here all the time, which means even if I hold the button down, it will always retry to light up the LED, so it will never turn off. So we'll need one more statement, and we're going to say this. We're going to say if, we'll set a condition, and it's going to be this pin is reading 1, which means it's getting power. Then we're going to rewrite to this pin high so that it will power up. So I'm going to delete this line because I don't need it anymore. And I'm going to start my simulation. So right away you'll notice the light will turn on, and this is because it gets to this statement and it reads it. It says if the digital read of pin 12 is 1, and it is because power is going from 13 into 12 into here, so it's reading power, then it's going to set the power for number 4 to high. Now watch what happens when I clear the serial monitor and click on this button. You should see this change to 0 and the LED begin to dim. So I'll clear it. I'll press the button. It's 0 and the LED is dimming. This is because it's not getting to that second statement, the one that says if digital read 12 is the same as 1, because it never is equal to 1. It's always equal to 0 as long as I'm holding this button down. And when I let go, the LED comes back on and the number changes back to 1. This is really important for you to understand because it shows you how you can have things on the board, on the Arduino, and then read what's happening on that section of the board and have it do something somewhere else. This is key for things like sensors, how cameras detect people, how microphones detect sound, things like that. And it shows you what to do with it. Albeit we're doing it with a very simple thing, a light, but it's still a really amazing thing to play with and figure out. All right, there's a lot more to this that we're going to get to play with throughout the year, and we're going to go slowly. And I say that a lot, but I really want to emphasize, we're going to go slowly, so you can always come back, relearn, or check things. If you feel like you don't know how, or it's tricky or impossible, don't worry about it. It's really not. Just take some time to watch the videos, ask for help, or think through it. Or if you want, you can look online and find lots of other resources too. Okay, I look forward to seeing what you guys come up with in class tomorrow when we do our next challenge and problem. But until then, I'll see you tomorrow.